Well, g'day, it's Ken Colson back with Dr. Matt McLain here at Creation Unfolding. Of course, Dr. Matt McLain, he is the Dean of the School of Science out at the Masters University. He's also the chair of the Department of Biology and Physical Sciences, and he teaches classes, I believe, in geology, biology, and paleontology. So, Dr. Matt McLain, welcome back to the channel. So just a little bit about yourself and any plugs you want to put in there, and we'll get into the topic at hand.
Okay, so yeah, I mean, you said what I do. I'm at the Masters University. I'm a professor here, and I am a vertebrate paleontologist, and so that's my research area is looking at fossils, and it's a lot of fun, and I get students involved here at the Masters University. They do research with me and take classes and things. So we're going to plug something. We have a conference coming up in February, and it's called the Think Biblically Conference. We're doing here at the Masters University, and it's going to include creation stuff, science stuff, as well as a whole bunch of other fields, including the humanities, engineering, all kinds of things like that. And so it's kind of an all-around academic conference, but geared toward general audience. And so cool opportunity if you happen to be in Southern California and you can catch that. Otherwise, I'd love to plug our Think Biblically website, thinkbiblically.org, where there's a lot of good video content. And then also just keep in mind in the summer, we're going to be doing another Origins conference, which is the Creation Biology Society, Creation Geology Society, and Creation Theology Society. And that meeting is going to happen in Dayton, Tennessee, and it's the 100th year anniversary of the Scopes trial. So it's gonna be a really cool opportunity to get out there, and it'll happen just after like a celebration commemorating the Scopes trial. And so it's a really good opportunity if you're interested at all in creation science stuff. That's exactly
where would they go website wise for those different things?
So the actual like conference webpage is not up yet, but if you want to learn more about it, I would visit the Core Academy of Science website, as well as you can visit the Creation Biology Society's website.
Okay, cool.
Yeah.
All right. So what do we got today? What are we looking at?
Today, we are going to be talking about therapsids again, which is fun. And for those of you who don't know, basically, used to call these things the mammal-like reptiles. That was kind of the name back in the day. And they're important in the evolutionary model because they are supposed to be the animals that are transitional between more reptile-like creatures that you would find in the Paleozoic to actual mammals that you start finding in the Mesozoic, going on to the mammals, of course, we have today. And so these animals have traits in common with both reptiles and mammals, and that's why they're often thought to be transitional. And so the therapsids as a group, they first appear in the Permian, and specifically in the middle Permian rocks. And so you first find them in a few different places in the world, kind of disjunct places. So South Africa is a big one, Russia is a really big one, and then also China, and a little bit later in Brazil. And so they're kind of just pop up suddenly without clear ancestry. And there's multiple groups of therapsids, right? So you've got like 6 different main groups that are found in the fossil record. Of those 6, 5 pop up simultaneously in the rock record. And so that's very unusual from an evolutionary perspective, right? You'd expect that you get like one type of therapsid and then 2 and then 3, like as time unfolds. But instead, it's like all of them just show up simultaneously, all the major groups except for one. And of course, the search has been, okay, where is the prototherapsid, right? Where's the thing that's the ancestor for these guys? And so people have been searching in early Permian rocks around the world. And there's good early Permian, or what we would maybe refer to as lower Permian rocks, but they're considered by evolutionists to be early Permian in age. There's good rocks with fossils in them of animals that you find in like North America. So like in Oklahoma and Texas, you get like Dimetrodon and that kind of stuff out there. And then Europe, you get very similar things too, like in Germany. But there aren't a lot of good places to look for this kind of stuff. And so the paper we're looking at is highlighting a new Permian locality with fossils in it in the Mediterranean. And there's been a little bit that's been found in France before and a few other places like that. But what's really cool about this new spot is that there's definite bones of a Therapsid. And that's the first for the Mediterranean. That's cool. On top of that, they're possibly the oldest Therapsid remains in the world, which is cool. We can talk about how they do the dating in a little bit, but they're suggesting that they are early to middle Permian, right at that transition. And then on top of that, they're able to identify these are Gorgonopsians. So Gorgonopsians are one of the types of Therapsids. They're the ones that have big saber teeth on the top and on the bottom, and they could open their jaws really wide to have these really big bites. So kind of think about like a saber-toothed cat, but almost like mix it with a reptile a little bit. And actually, I can show you a picture. They've got artwork in this paper. Here, I'll share it with you. So I'll zoom in here so you can see this is artwork by Henry Sutherland Sharp showing a Gorgonopsian, and you can barely see the saber teeth right there. Because you look at that first, you're like, oh, it doesn't look anything like a saber-toothed cat, right? So if we go up and look at a skeletal diagram here, you can see the big saber tooth coming out from the top jaw. And then you can see here they've actually got quite a few bones. They've got like a whole leg. They've got some vertebrae. They've got good chunks of the lower jaw and some of the skull and teeth. And it's this combination of bones that they can say, oh yeah, this is a Gorgonopsian. That's a definite member of this group. And you say, why is that remarkable? Okay, well, let's take a look down at our phylogeny here. And let me zoom out a little bit so you can get a better look at that. You can see here with this diagram, this is a phylogeny, and you've got the geologic column going along the bottom here. And so the orange layers here, these are Permian rocks, and that's what we're interested in. So at the top here, you'd have, what would be considered the more basal members of this group. So Therapsids are part of a bigger group called Synapsida, and these animals, the more quote-unquote primitive or basal members of Synapsida are called paleontological. And you can see some of those there. The most famous one is Dimetrodon. This is an animal lots of people have heard of or at least seen. Mm-hmm. And so you can see how these animals are exclusively either Carboniferous or they are what we call, lower Permian rocks. They're early Permian in the time scale. And they're, the ones that are supposed to be the closest to Therapsids, these sphenacodonts here, they're all disappearing before you find Therapsids. So your first Therapsids are up here in the middle Permian, what's called the Guadalupian. Mm-hmm. And so you can see there's 4 of the 6 Therapsid groups they're showing you here: the Dinocephalians, the Anomodonts, the Byromasuchians, the Gorgonopsians. There's actually one Theracephalian here as well. And notice that all of these are essentially popping up at the same time. They're all here in the Guadalupian, or the uppermost part of the Guadalupian. And so you've got your main Therapsid groups there. And so ours, the little star right there, this Gorgonopsian that they found in the Mediterranean, this thing is a definite Gorgonopsian, and yet it's very early. So what they're showing you here with this phylogeny, they've kind of used that data point to push all the time back on this. Okay, so whereas before they're thinking Gorgonopsians, your first fossils are higher up, they're being pushed deeper now. And what's interesting about this is, well, it's a number of things, okay? So with this being your first Therapsid in the fossil record, potentially, you'd say like, oh, this is probably going to be some kind of like proto-Therapsid, right? Something that's like a transitional form between these pelycosaurs and a Therapsid. Mm-hmm. Nope, it's a full-blown Gorgonopsian. And not only that, when you read the paper, they make a case that we don't even think this is the most primitive Gorgonopsian we know of. We actually think that it's kind of more nested inside a Gorgonopsia. And so that's really surprising. And what that means phylogenetically, at this point, if you've got Gorgonopsians, you must also have Theracephalians, Byromasuchians, Anomodonts, and Dinocephalians. They've all got to be there, even though you haven't found their fossils yet, just based on your phylogeny. And so this is interesting that, your earliest Therapsid fossil, it's not really helping you understand Therapsid origin at all. It's actually just pushing everybody down again. And that's very fascinating. this is kind of what we'd expect to see as creationists. You'd expect these distinct Therapsid types. We're not finding links between them. We're not finding links to other things. We're finding discontinuity separating these things. And even when you find earlier fossils, you're still able to place them in groups that you already know about.
Mm-hmm.
And so that's really interesting. And just to show you kind of where they found this, like I said, the Mediterranean, this is the Balearic Islands. These are islands that belong to Spain. So they found it right here on, I don't know if it's Majorca or Mallorca. I don't know how you say it. I'm guessing Majorca. And
Are these different Therapsid groups quite different from each other?
Yes, they're very different from each other. So you can see from the silhouettes here, Gorgonopsians, like I said, are these predators with saber teeth. These are things that would chase down and kill other things. Versus a Dinocephalian, the Dinocephalian they have there is something kind of like a moss chops. These are big, bulky herbivores. They're kind of, think almost like a hippo, just kind of walking around. With very thickened heads, typically for butting into each other and stuff. But then there are some that are also meat eaters, and they would have very big jaws with sharp teeth on them, but they're very big, bulky animals again, very large. And then you contrast that with your anomodonts here. Most of those are what we call dicynodonts. They have a beak and big tusks. So I've got a dicynodont skull replica here. It's a 3D print. This is the skull Lystrosaurus. And so you can see the eye right there and the tusk that comes down right here. And this is a beak right there. And so they're kind of funny looking animals, kind of like a pig, but with a beak. And
so a lot of very disparate organisms.
That's right.
That sort of turn up all at the same time.
Right, exactly.
That really shouldn't turn up.
That's not what you'd expect, right? You'd expect one type of Therapsid and then a few more and then a few more. And so, back in 2009, one of the Therapsid workers, Thomas Kemp, he compared the sudden appearance of Therapsids to the Cambrian explosion and to the sudden appearance of mammals in the Paleogene. He said it's a very similar phenomena. And in fact, he made the case that the fossils are so close together when they all appear, and actually working out who is the closest relative of whom among all these different 6 types of Therapsids. He said, I think it was an actual polytomy. What he proposed was that what we get as a polytomy sometimes when you have multiple branches coming from the same origin instead of just always 2.
Right. So like on that cladogram you had there, you can see that each one of those branches twice.
Right.
And that's normal,
here,
right?
You do have a polytomy right up here, right? Where you're seeing multiple branches coming out from the same spot.
Right.
And you're not supposed to get that.
That's not sort of not allowed, right?
Yes. And so when you get one, you're like, oh, that's because it's not resolved correctly. That just means that you don't have enough data or there's something wrong. But he was saying the branching off of this group and this group and this group and this group, he was saying that might actually be a true evolutionary polytomy. What he thinks is that they appeared so rapidly, had such a fast adaptive radiation that you will never be able to actually reconstruct who's the closest relative.
And I think the reason the polytomies, and I could be wrong here, are not allowed is because of the premise of deep time, right? So and how long it takes for organisms to evolve. So they shouldn't just all evolve disparate organisms really in a really short time. So you should always be able to bifurcate. Is that right?
Yeah, you'd expect it to kind of bifurcate for the most part, right? Like you'd expect, think how you think about evolution works. You've got a population of organisms and, some of they split into 2 different populations. It's possible they could split into 3 or 4, but in general, you tend to think of always splitting in half kind of, or like a group branching off from this group. You don't expect like 4 groups to suddenly appear out of one. That's kind of unexpected. And yet you've got an evolutionary, paleontologist who's saying, I think that's what happened. Because there's just a sudden no Therapsids, then boom, you've got a bunch of different types of Therapsids. So it's very much like I said, the Cambrian explosion, right? Where you've got, none of these types of animals, and then all of a sudden, boom, you've got a bunch of types of animals.
Yeah.
And this is
exactly no precursors kind of either, right?
That's right. Yeah. So you've got, like I said, Roranimus. It's essentially contemporaneous with all these other ones. It's found in the same deposits as anomodonts and some other animals like that, right? So it doesn't really serve as an ancestor. And then your closest pelycosaurs, the most similar ones, there's a gap. And that's what they're showing you here with this chart. It says early Therapsid fossil gap. You can see right there where you don't have the precursors. And so this is what we would predict as creationists, that this isn't because these animals are evolving over time and we're catching that. It's because you're burying catastrophically the deposits that these things lived in over shorter periods of time. And so you're switching from one type of community to a different type of community getting buried.
Mm-hmm. Yeah, and even like the groups of therapsids, they supposedly evolved from the pelycosaur, quote unquote, group, and they're very different too, right? Like the pelycosaur group,
Yes, they're very,
and the
very
therapsid
different.
group are very different as well.
Yes. So there's I was just working on this the other day. I mean, people have come up with lists of dozens of synapomorphies that unite Therapsida, right, and separate them from pelycosaurs. I mean, they're very unique animals, very distinct
So a
animals.
synapomorphy is a new trait.
Yeah, a trait that would unite a group that's not found in, the ancestral group in the evolutionary model.
Right.
And so, this is exciting. When I read the title for this paper, I'll go back and show this: early Middle Permian Mediterranean Gorgonopsian suggesting equatorial origin of therapsids. Almost every word in this, I was like, had to do a double take. Like, wait, what? What are we talking about? Because none of these things should go together. This was very shocking, very surprising research, and very cool. And so, regardless of your belief system, this is a cool discovery. But it's particularly interesting for us as creationists because we do expect to continue to find these discontinuities. We do expect that, the earliest therapsids you're going to find, you're going to be able to define them as therapsids, and that these groups are going to remain distinct, right? You're not going to find something that's like the ancestor for a Gorgonopsian and a, Dinocephalian or whatever. But also we would expect that there's these sudden ecological changes in the creation model, that you're not just slowly turning one environment to another over millions of years, but you'd expect to find like, boom, this type of deposit is made, and then boom, another type of environment is buried on top of it, and which I would think is attributable to the global flood. And so that's really exciting to me, to see this exact kind of thing. Now, the actual dating for this is pretty complex, and you can go and read their section on here and how they dated it. They're using a bunch of different methods, which you should, right? They're doing good work here on comparing palynology with magnetostratigraphy, with the fossil trackways that they're finding, all of this kind of stuff, piecing it together where they've got a range, and they're like, well, we're not exactly sure where it is. But it really does, they make a good case that it's looking pretty early. It's possible that this is genuinely from lower Permian deposits, or what you could consider early Permian. It might be from the absolute earliest middle Permian deposits, but either way, this is like very, very shocking to see a fully formed Gorgonopsian right there at the beginning, possibly first therapsid in the fossil record. And so we can make predictions. I suspect they're going to be finding these other therapsid types at this deposit too. If they can find enough fossils out here, if they're preserved, and these rock layers out here, people should go looking with permits and everything. But I suspect they're going to find Dinocephalians. I suspect they're going to find Anomodonts. I suspect they're going to find Biormasuchians. These things are going to be there, and that's cool. We can make some predictions based on what we find in other localities around the world. And this may reveal some details that we're lacking because all of our current therapsid bearing localities, the earliest ones, if you have a map here, are all from high latitudes. So either the high northern latitude or far southern latitude in Pangaea, and even today, other than, like I said, later we start getting Brazil.
So this map you're looking at right now, that is Pangaea.
Yep.
So we're looking at where these fossils originally came from.
Right. You're looking at how the Pangaea is coming together. And so when these things were being deposited, I would suggest that these are happening during a global flood. But the questions here this starts provoking in the mind for the creationists are really exciting. We see this stark contrast between these Carboniferous and lower Permian deposits versus the middle and upper Permian deposits, where you have drastically different animals. You see a change in plants that's very significant in the uppermost Carboniferous, where you stop finding certain types of plants and start finding more of other types of plants. And if you look at, I think I've got it open. I'll show you. Oh, I just saw it. Kurt Wise did a really interesting paper for the ICC, this last ICC, so 2023, called What Biostratigraphic Continuity Suggests About Earth History. He had a co-author, Donna Richardson, and they generated some very fascinating charts in here, just using the paleobiology database, comparing it across Earth history, looking at how many taxa cross boundaries, stratigraphic boundaries. And they found you could divide up the rock record pretty clearly between like a very early part, so like a Precambrian, Cambrian chunk. There was kind of an Ordovician to Mississippian. Then there was a Pennsylvanian to Permian. And then you had kind of the Mesozoic and then the Cenozoic. What did I say? 4? 1, 2, 3, 4, 5. Sorry, 5 zones that they found. And so they attribute the post Mesozoic, so the Cenozoic part, they think that that's post-flood. They would interpret everything down in here to be flood, maybe even this stuff down here to be flood, but there's some debate here, which is interesting. And of course, you've gotten into that before about flood boundaries. But what's really interesting is this transition. Look at the kind of the lower Paleozoic stuff, and then the lower, really the Mesozoic stuff. There's this very fascinating spike you see right here in the Pennsylvanian Permian, and it goes throughout the paper and discusses it. But what Kurt and Don Richardson suggested is that what you're seeing is the destruction of the floating forest, right? So the floating forest plants, you can find fossils of these. Kurt Wise proposed back in 2003 from the Silurian all the way up into the Carboniferous. What he was suggesting was a floating forest environment. It was a pre-flood environment off the continents, basically giant floating forest. And you'd have very particular, unique animals that would live there. And so what you would say is the Paleozoic stuff you find fossil-wise, it's marine or it's floating forest. You're not actually finding true terrestrial deposits, truly terrestrial is what he would say. Mm-hmm. The Mesozoic, you find truly terrestrial and truly marine stuff. The transition right here, this Pennsylvanian to Permian, they're suggesting that this is the breakup finally of the floating forest, where you get a mixture of marine, terrestrial, and floating forest stuff all mixed in there. Mm-hmm. And so what we might be seeing then is the final breakup and burial of everything in the floating forest, transitioning to our first terrestrial things. I would suggest, potentially is what I'm thinking about right now, is that the Therapsids are representing your first truly terrestrial community, and that the Pelycosaurs are part of that floating forest, and they're being buried catastrophically, and a few of them either did live in the Therapsid community, so some of our Caseids and our Varanopids, or they've been basically dragged into these as the floating forest is being destroyed and brought onto the continents, kind of beaching itself on continents.
Right, so this would explain why you have the Pelycosaurs lower in the fossil record.
Right, is that they actually, if I can go back to the paper, they actually lived in a different community. They were not part of this ecosystem.
Right.
And so the Pelycosaurs would be mainly floating forest inhabitants, whereas Therapsids would be actually living on coasts or sandbars or things like that.
And just, continuing on with that idea of different biomes, that's why maybe we would have amphibians and these kinds of things even lower down than the Pelycosaurs.
Right.
In the fossil. So they would represent sort of the edge of the floating forest and the marine environment. The Pelycosaurs represent sort of the floating forest, which is sort of a floating terrestrial environment, if you like. Mm-hmm. And then the Therapsids would represent sort of more right on the shore, right at the interface between the floating forest and the terrestrial. And sort of that might explain why we have them in that sequence in the fossil record.
Right, and that's that's what they're observing with the paleobiology database data. And what we're seeing here is that there's these discrete units. You don't just have this blending or this total spectrum. Like you could actually pull out not only distinct biological units, like we are saying, these different categories of therapsids, you can point out distinct communities and depositional styles, even sometimes, and depositional environments. And that's really fascinating from a creationist perspective, what this might mean. And so, yeah, you brought up amphibians. The amphibian fossil record is really interesting too. We talked about it before when we were discussing I think we talked about aestropods, maybe some other groups, or maybe we were talking about our first uh, Sicilian fossils. I don't remember which one it was, but that in the Carboniferous, you have tons of types of amphibians, just tons and tons and tons of types, right? But at this transition from, going into the Permian, you still keep a lot of those. You still got some Nectridians like Diplocaulus, the boomerang-headed guy, and some stuff like that. But then once you get into these Therapsid deposits, you do have amphibians. They're around, but they're much more restricted. There's much less disparity than there was. You really just have a few types of amphibians, and then that keeps diminishing even to the Mesozoic.
Right. So as their environment is being destroyed, they're right. becoming fewer. Their species diversity is lowering. Their numbers are getting smaller.
Right. And so, even in the pre-flood world, my guess is you would have had a lot more types of amphibians in a floating forest environment. That makes sense. Like that would be a good community for them. Versus in the more terrestrial realm, there aren't as many niches where these amphibians are going to fit in really well. You're going to have maybe a lot of species of them, but they're more restricted in terms of what they're doing disparity-wise, right? So you might only have a few categories of them doing some very specific things, whereas earlier in the Carboniferous, you had a bunch of different types doing a bunch of different things because that was a floating forest environment where they lived.
Right. And of course, I mean, I've got to just insert my own perspective here. You talked about flood boundaries. So right. I would most likely interpret everything that you've just said as correct, although I might extend the time frame being pre-flood. So the floating forest is slowly getting broken up as you've got ground movement, disasters, catastrophes going on, increasing in intensity until you get to the flood proper that we see in Genesis 6-9. So you have the floating forest breaking apart. You have these communities being buried over maybe decades or hundreds of years until we find we get the flood maybe sometime in the Mesozoic.
Yeah. So there's different perspectives out there.
Yeah.
And, this is how science works. And so, I think many times we can be guilty of approaching science as, well, I want to find an answer to this one particular question that I have, and not be excited about what's actually out there. And so, I think this is a good thing Todd Wood commonly challenges people on, is like, you should be excited about scientific discovery. Everything that we're finding in science is something God made. It's something he was doing. It's something that we're seeing aspects of his glory that are on display. And they may not answer specific apologetic questions that we have, but that's okay, because it's another piece of data. It's another thing to go and discover. It's another piece of the bigger picture. And so sometimes, I guess my point is, sometimes we miss the bigger picture because we're just interested in winning a debate or just interested in this one question, and we should be excited about the things that are out here because they're giving us a grander and larger picture that we otherwise didn't know. And that's what we should be hoping for. And that's something I'm respecting more and more and finding more and more as I look at therapsids, that it's really kind of opening the door and widening my perspective of what God has done. And maybe in some ways I'm leaving more confused than I began. Other things I am understanding better. Mm-hmm. But it's giving me a richer and deeper understanding of God's creation. And that is ultimately should be one of our goals in science.
Absolutely. All right, cool. Any other little tidbits you want to add on there?
No, I don't think so.
Okay. Yeah, I think it's important to talk about the fact that, as creationists, our model is in flux, right? I mean, we don't have a model that is as precise as the evolutionary model. And I think that's the reality.
Yeah.
And so, as creationists, we have different ideas on things like flood boundaries, different ideas on the amount of diversity that's going on in organisms and things like that. And that's all okay because that's science.
Yeah.
We're looking at the science. But we never go beyond what the scriptures are teaching, the basics of what the scriptures are teaching. But so I'd say really in the last maybe 2 or 3 decades, we've really been accruing a lot of information and putting together a model, but it's still in flux. And I think our viewers need to understand that we're still trying to get this information together. And in reality, we're only a very, very small community of scientists. And it's only in the last decade, really, that we've seen an explosion of young scientists graduating with advanced degrees that are able to do research in these areas. Right. And so it's kind of exciting to see, like at the Masters University, you've got lots of students there that are graduating with degrees and going on to get advanced degrees. And in other universities as well, like at Cedarville as well, that's happening. And so who knows, in 20 years, a couple of decades, we might be able to really put things together into a much more solid model. But that I say that for us as creationists to be humble.
Yeah. Well, and you raise, oh, sorry.
Go on.
I was gonna say, you raise a really good point. Like, hey, the evolutionary model is so, there's so many people working on it, it's so much more detailed, so many more things that fits together well. But then, even with this, you find a discovery like this overturns what they were thinking, right? They were like, oh, Therapsids obviously originated in the higher latitudes and originally came from, these what we are considering floating forest communities, Carboniferous, early Permian communities that were tropical. Animals moved out there and evolved in the higher latitudes and then kind of migrated back. And then, nope, here we are finding fully formed Therapsids in equatorial regions. And it's like, oh, well, we got to completely retell this story that we've put in textbooks and that we've done over here, and we've made models based on it and everything. And science is constantly in flux. Even if we had a really, really strong, well-documented, tons, hundreds of scientists working on a flood model, we'd still have big pieces that we'd be constantly changing because we discover new things.
Right.
And that's not bad, that's good. But we're not even at that stage yet with the flood model. We're still very much where we've got competing ideas going on, and that is exactly where we should be based on what we know and how many people are working.
Yep, good. So for the viewers out there, when you're getting into discussions with atheists or people who are believing in the evolutionary model, just be careful what you say, be humble, understanding that creationists have different opinions on things because we just this model is in flux and we're trying to put it all together. But our ultimate authority, of course, it is the scriptures, right? Yep. It is that what the Bible teaches is true. And that is a massive piece of evidence that we accept, and it trumps all scientific evidence. So some good things to keep in mind there. All right. Well, Dr. McLain, always a privilege to have you on. Some fascinating insights there that we looked at. Don't know what we'll talk about next time, but I'm sure it'll be interesting. So, Dr. McLain, thank you. For those who are interested in getting an undergrad degree in the geosciences, please, if you're even just thinking about it, contact Dr. McLain. You'll find his email address online. And look at getting involved at the Masters University. It'll be great stuff. So that's all from me, Ken Colson, here at Creation Unfolding. Don't forget, pound the like button and share this on your social media platform. Pray for the ministry. I really, really appreciate that. There is a link in the description if you'd like to give as well. And we will see you next time. Thank you and goodbye.